have my presentation, and there it is. So it's a glorious 5-hour presentation, a salute to DPDK. Oh, okay, you guys can figure out where that came from. Bruce probably already knows. So what we're trying to do is figure out how to make DPDK a little more user-friendly or cloud-friendly. Because DPDK now, we've talked about the command lines, we've talked about everything else. So we're going to try to figure out how we can reduce that, right? What is its resources that it consumes? How does it consume them? Why does it consume them? Try to come up in a minimal set, possibly, right? And Bruce talked about a bit of that. And then there's some other pieces we're going to talk about as to how to deal with non-DPDK experts programming DPDK. And it's just going to be an example. But one of the big problems is, how do you configure DPDK today at runtime, not at init time? So we can always reduce the number of command line options, but that never happens. I haven't seen us deprecate one yet without replacing it. So we can try to do that, or we can come up with some other mechanisms. And what Bruce and Thomas had talked about sounds reasonable to me. We just need to do it in the right way, and I think it'll be a lot of help for people, especially for the people who are writing their application on top of DPDK, not just writing their application within DPDK. So we need to be able to configure it easily while it's running, and also monitor it, get stats from it, without having to write some special interface for it. And I'll go into that as well. And the other part is the orchestration layer. We don't want to create something super special that the orchestration layer has to create a plugin that does it and figure out your protocol, talk to your application or DPDK, and get the information. That's kind of a non-starter too, right? So we look at the different parts of it, of maintaining performance, and also being able to configure it and be able to react to a change in this system. So that's the second to last line is kind of like, there's a lot of DPDK non-experts out there that want to use DPDK, but we've got all sorts of little nits and knobs and stuff we have to tweak for each driver, and they have to know the driver, or they have to get the information from the driver. There isn't something simple to do that. So can we make that simpler for them? Not necessarily changing the DPDK, but doing that for them at a slightly higher level of APIs. So from my perspective, command lines are great for developers. They're horrid for anybody else to use. Because even in packet gen, I have fairly few APIs or line configuration options, but they always get them wrong. And I write a lot of documentation for it, and they still get it wrong. And DPDK has a lot of documentation, and they still get it wrong, because they don't quite understand what's really happening with those APIs. So it's not anything of our fault per se. It's just, if we don't give them anything, give them the minimal. And I think that was Bruce's point. So we need to start up fast, which we've done a good job of. Antonelli has done an excellent job of reducing the memory requirements, giving us a fast startup time. And that is a big benefit. We also have to watch the drivers themselves to make sure they don't consume a lot of time starting up either. So, but that's kind of a different point. So the threads, as Bruce touched on, and the cores, that needs to be dealt with, because we do need to have some sort of manageability of a process. Now, I don't have a perfect solution for it. I did create a POC that Bruce was looking at that allows you to remove and add cores to a process, a running process. But that's not the full solution. So there has to be more to it than that. And maybe we need to rework it so that it's more uniform, because I just kind of tacked it onto the side. I didn't want to go in and change all that code. For one thing, you want to make sure backward compatibility is maintained. So from the dynamic side resources, from my perspective, we really want to be able to start DPDK up with nothing. And that was kind of Bruce's point. And then add to it, right? Add the cores, add the memory, add the drivers. Build it up to what you want, and then be able to take that away as needed, right? There's some of them that won't, there's certain cases where being static is just fine. But there's other cases where you'd like to be able to scale up and scale down. So that POC I talked about, it just did add and remove, and that's all it did, and it seemed to work fairly well. Didn't have a problem, but you still have to notify the application that you actually are taking that core away if the orchestration layer comes in and takes it away. And then he has to say, yes, you can take it away. You can't just take a core away and leave him hanging, right? Now, we have the dynamic hot plug stuff, but I think it needs to be even expanded out to the virtual devices as well, being able to bring in and start up virtual devices at the same time, not just physical devices. Now, the hot plug kind of handles that. The virtual devices should be a lot simpler to do from startup in that perspective. So one of the areas I was thinking about is, well, how do I configure all this? How do I get someone to be able to manage a DPDK or an application within DPDK? And it's not easy unless you have a command line like package-gen. Yeah, you can do all the configuration you want, but that's what I thought was the configuration and what the stats were and so forth. So we need to come up with a more raw input or output so that they can manage this thing. So I decided to look at the Fuse file system. And in this particular case, we write the back end for the Fuse file system to sit inside the DPDK process. Okay? And it's running on a free-floating thread. We don't necessarily have to pen it to a thread. Okay? It's the back end side from the kernel, right? And I have a POC that does this as well. And it seems to work really well. I went in and done some low-level code for DPDK and basically did the shows, take the show, dump it into a file, type mentality, and so forth. Stats, if there's a lot of it, we dump it out in JSON format. If it's simple stuff, we dump it out in just plain ASCII, like the version number or the number of cores or something like that. But now, from the host command line, you can CD around in there just like proc or sys directory. And cat those files, do whatever you want with it. It's a common interface for everybody to understand. All your plugins can deal with it because it's just reading file system now, right? Yeah, you might have to write a specific type of thing. But the back end is connected to the kernel's Fuse system. And right now, I decided to put it at /DPDK. And underneath /DPDK, you'll have the name of your application with the process ID. And everything under that is associated with that process ID. Now, an application can then also add his, because if the application is running within DPDK. He can add his file systems and files. And this is all dynamic. These aren't something we hard code, so you can change them. May not want to change the DPDK ones, but at least for your application, you can do whatever you like in your directory path. And it seems to work really well, be able to get those stats out and so forth. Trying to get to what the directory paths look like within that file system and what the files are that you want to display. Those are pretty trivial as well. The Fuse library, Fuse 3 library, has a lot of file system opcodes that come up from the kernel to do all sorts of things. Well, it's a little daunting for some people to look at that code and say, oh, I've got to support 50 events that come from the kernel. Well, no, not really. What you really need is I created the layer underneath this, or just above, sitting on top of the Fuse file system library, that does all that grunt work for you, because it's all pretty much cookie cutter, right? Open a file, close a file, read it, write it, whatever it takes, right? Set the permissions. And then I created a small layer on top of it that you only take about 5 events read, write, close. There's no close, actually. It's called release. And it's a different connotation than close. Open, init, and that's about it. That's all you really need to see in your file system. So I'm not going to read all this stuff, but if you don't know about Fuse, you can get the download and come look at this. I will try to make sure somebody remembers all those names under there. So Fuse is a pretty standard thing now in almost all the file systems. It does exist in other operating systems, various supported features of it. It is supported in FreeBSD, but I'm not exactly positive how well supported it is. It's supposed to be supported to Windows. That's another issue, right? But Fuse at least works very, very well in Linux. So what we're going to try to do here is take a DPDK application, and right now I'm just dealing with DPDK, is we'll set up there this libfuse interface that connects to the kernel, which is a socket interface, and then we have the simplified Fuse interface that I created. You basically, I stole a lot of stuff from the command line interface that I had, because I already had nodes and inodes and that kind of concept, right, and a directory paths in that code. So I took some of that and used it here as the concept for it. So you can create all your inodes and so forth. That's what Fuse deals with. But you're dealing with just paths within that subsystem. And what the permissions of that file are, whether it's read or write, that kind of thing, right? That's all. So your application or the Fuse backend for DPDK, you can walk over and CD and down into the port and say cat stats, and it'll spit out in a JSON format right now. You could cat another file, and it could come out in some raw format. I don't really care. But it's just how can you consume it? And JSON seemed like a good opportunity. I'm using the Janssen, Jansson library. But that just seemed to be the one that everybody in Intel was trying to use. So with the simplified interface, it seems to be very easy to deal with. Now, we'll get into the details of it and see if it really is, but it does seem to be a good way for everybody to be able to modify or at least monitor DPDK. Now, this is one of the, if you can see it actually, I just kind of created a file system and dumped stuff in there. So I tried to go get all the show files or dump calls, and I dumped them into this file system. Now, some of these calls are done at the instant you ask for the data. Some of them aren't done at that instance, like the copyright. It's just there. I don't have to do anything with it. Matter of fact, I don't even have to touch it. The files, I just tell the file system that it's there, the file's there, and he does all the read and write access underneath that simplified layer. All I get called into DPDK or into that simplified layer is an init, and that's it. And you can make these come and go as you will, as you please during runtime. So if you have some plug-in that pops in, he can populate his own path into this tree. So that was the Fuse file system. I think I'm going to wait to the end and let you guys do this, because I don't have much time, and I also have a lot to go through. So one of the other things I decided to create, because I kept getting asked for it, was an API for non-DPDK experts to use. But I didn't want to necessarily modify DPDK APIs, because I still want people to use those. So it's a layer on top of it, and what I wanted to make sure is it had very little, if no, impact to performance. Okay? Because that really defeats the purpose if I drop the performance by 50% to get this done. So that was my goal. Some other people say, oh no, I want it even much higher level. Well, that's going to give you another level of performance hit. Like if you want to do read or write. Well, read or write is effectively a copy operation, right? So you don't want to get copies. Sockets the same way, unless you modify sockets and do it in some other fashion. This is similar to DPDK APIs, and there's probably better ways to do some of this piece. I got the layer 2 forwarding app working within a few minutes after I wrote this stuff, and it runs the exact same performance. There's no difference, because you'll see the APIs are very close. Did I hit the right button? Yeah, so the green box there in the middle is this DPDK application called DAPI. DAPI doesn't have to be used. You don't have to use it. You can even bypass it if you so to choose. Use part of DAPI and bypass it if you like. But there may be a lot of APIs we don't even convert, because who cares? The ring interface is the ring interface, leave it alone. If we can't add any substantial upscaling of that interface for the user to make it simpler, then why bother, right? So most of the calls was like how you init. You know, there's typically in almost every program, there's probably 50, 60 or more lines of code just to initialize a port, right? Get this, do the configure step, do the setup step over the queue, do the start, you know, all this stuff, right? Well, let's simplify that. Let's try to make sure they don't have to understand DPDK at all. Abstract some of those pieces away and make it so they don't have to worry about DPDK APIs. Let's take an interface that requires you to build this structure in this bitmap format and then shove it down to the NIC. Why? Why can't the guy writing the code say, oh, I just wanted to turn on CRC? Well, CRC on, port, or whatever you want to call it. So we're really just trying to simplify it, trying to make it as fast as possible, trying to make it as easy as possible, taking the defaults, as we were talking about earlier from Bruce. Most of the people take the defaults from the application perspective. They might go and tweak a couple of things, but that's about it. Allow them to be able to do those tweaks without having to fully understand everything else. Utilize inlines and macros wherever possible to make sure that we at least eliminate as much overhead as possible. I really like the idea of trying to hide some of this stuff away from the application provider as far as the DPDK intrinsics or the internals of DPDK, because it just makes it a little simpler for them to understand, especially if you provide just a read and write methodology. Like when they're dealing with a file system, they're just doing open, close, read, and write. What do? We do a lot more than that, but we try to get performance too. So there's going to be a little bit of give and take. Now, typically applications, in most cases, some of them, they don't quite understand polling. I have to poll? What am I doing polling? I just do a read in my application or something of that nature, you know, something that's a blocking call. Well, hide the poll inside that layer. He does a request, and it sits there and does the poll for him. If he doesn't need it, he doesn't need it. But, you know, make it a little simpler for him to understand. So we're looking down into this API, and I'm probably not going to get through the entire API. I don't even know how much time I have left. Someone will probably tell me, I bet. 15? So, like I said, almost all of the libraries and stuff like that, they're pretty simple APIs. Why bother abstracting those away to make them simpler? If we can, we can, but it may not be necessary. A lot of the places is having to deal with init and how you call into DPDK, how you know what port 5 is, Q7 is, right? You have to know that in your little brain somewhere. Well, someone smart in the company will probably be able to tell you which one that one is, but why not give them a simple moniker, a string that says, this is what it is. Oh, by the way, I'm the smart guy. I told the code underneath that that's what it was, port 5, Q7, or whatever it is. And we'll get to that API in a minute. They almost don't need to know about mbuffs. They're just really primarily concerned with data, right? So yeah, you can go back a void cookie or void pointer that looks like that's an mbuff pointer, but they don't need to know it. Do they need to get into the mbuff structure? Probably not. We have a lot of getters and setters already in the mbuff. So let's just propagate that. So this is what I came up with. You can argue whether it's good or bad. The DBK EAL init, the only reason I do this is I want to call RTE init underneath the layer. And somebody always calls me when I'm on stage. So you pass the same arguments, but you have a third argument, which is the DAPI object pointer because I'm hiding some things away from you. I'm hiding things away from you like the buffers for that particular port, okay, and so forth. There's other things I hide away from you that you don't need to know or keep track of. So in that particular case, I just call that, and it effectively just does EL init. It may call the DBK fuse file system init. It may do something else, right? But we can put whatever we want in there, or we can have them add things to it. I mean, they can still call EL init, but the problem with this is I need to know some details. I allocate a structure to keep track of DAPI. Now, the open and close, you go, oh, well, I know what the port is, and I know what the queue is, but somebody else might not. So why don't you give it a string that's unique to you, and all they have to do is open that string, and they get back a file descriptor index. And I keep track of that. Or somebody programs that knows what those are into the application, and it could be called anything. Foo, bar, I don't care what it is, Fred, right? And all he has to do is open up that Fred, regardless of whether it's port 1 and Q5 or port 5 and Q1. He doesn't care because somebody else knew what that was. You can have, in this format, the string itself could try to decode what the port in Q is if you want to do it that way, like /dev/5:3 or something like that, right? You could do it that way. I'm not going to say you have to. But that's what I was looking at. But we return back this file descriptor index that indexes into a file descriptor list, just like you do in Linux. And now you use that little pointer or that index to talk to everything else within the system. That's basically what the close is doing. So the buffer pool create, I kind of simplified it a bit because there's a lot of defaults in that silly thing, okay? Most people don't call, and set up the callbacks for setting up the buffer and the so forth for the callbacks. They don't do that. Or whether or not it has headroom or not. They don't do it. So I want to give them a simpler API. Now that's just me thinking to make it simpler. And also it eliminates any DPDK isms out of that code. Now the default port config, that's for you to set up what you think your individual ports should be if you want to do it that way, okay? So this is a shorthand way. You should go in and you do it once, make that call, pass down a table, and then everybody else can just utilize it. Or you can do it individually to configure a port. But the call to set it up is fairly simple. I take almost all the defaults for the port. So if you want to change CRC, we'll have to add another something to say set CRC. Okay? Now these aren't done, far from it, but I'm hoping it makes it simpler. So the buffer allocation, you notice I didn't pass in the mempool pointer. I already know what the mempool pointer is. It's sitting in my DAPI structure that I created when you did the open for that, because you took a default value, the number of mbuffs you wanted for that thing. We can set that up some other way. So now you can allocate an mbuff, well, what I call a packet buff, and now you can push and pull data into it and not have to understand the mbuff structure itself. Same way with the free and then the bulk allocate and so forth, right? I'm trying to be close to those APIs, but not necessarily. Now, if we could abstract this even higher, I'd be happy with that. But this is what I came to. Now we have the read and the write for a single one. That's what you guys like to see. It isn't the semantics of read and write like you have in libc, but it is just passing down one mbuff and getting one mbuff. That's the sole purpose in life. You can say that that's just a semantic sugar over the top of the bulk gets, right, and sets. But you notice I also pass in the index. And then the flush. In almost all instances of the application, a write or a transmit always gets queued to a buffer or a list someplace, and then gets flushed when it gets full or whenever they tell it to flush it. So just build it in. Don't even bother asking them. You're going to just build it in, put it on a list, and flush it when it gets full or when they tell you to flush it. Okay. So I'm probably not going to get through all the rest of this stuff, but I'll kind of give you a brief tour of it here. So we have just the lengths and stuff like that. Most of this stuff is all glommed from what's happening in the MBUFs today. This is an example of how you register your devices. So I'm just registering, that string, and it could be anything, and specifying what the port and the queue ID is. And that needs to be expanded, okay? But this was a simple case. And then remote launch, one of the issues that I did, or why I called DAPI EL init, is because I also have a thread local pointer for every thread that points back to DAPI. So you can get to that structure at any place from within the thread. And I need that to be able to do this launch for you, okay? And I have to jump through a separate function to be able to set that variable. Maybe that's not the right way, but that's kind of what I was getting to. If somebody has better ideas, that'd be great. I think it would be a big benefit to some people. And it really isn't that terribly difficult. I reduced quite a bit of code out of L2 forward just because just the port init itself was 50, 60 lines of code, and fairly complex. So anyway, that's my spiel. Any questions there? Don't jump up too fast. We don't want the blood rushing to your head.
Is this just a library, or you also have a directory with examples of usage examples?
For DAPI?
Yeah.
It's built into a library, okay? It has nothing to do with DPDK. It's built on top of DPDK, and it doesn't change DPDK, okay? So you can link it into your code or not and use it. Is that what you were asking? Oh, a demo? Yeah, I just haven't pushed it anywhere. I can do that. It's very, very simplistic right now and probably missing a lot of things, but I can try that. Same thing with DFS. I've done the exact same thing for that. I have a POC for that. That one's probably a little more complete-ish as far as standalone goes than the DAPI interface is.
So, Keith,
yeah.
You mentioned that this is optional.
Yeah.
But at the same time, you said that it's going to make life simple for the applications. So
simpler for the people who aren't the people in this room which are experts in DPDK. Okay. Oh, I know which API to call, and it's got 15 different arguments, and I know every last one by heart.
Yeah,
and by the way, 12 of them are defaults.
Yeah. No, I'm wondering why can't it become the standard?
Say that again?
Why can't this become a standard for DPDK?
It could. I don't have a problem with that. Bruce suggested that it become part of the DPDK API. I put it in a library to make it not as intrusive to DPDK for some people. Some people will argue that I'm taking away all their power. I didn't take away anything. But if I shoved it into DPDK as a standard API, they might argue that, and I don't want to do that. I just want to present a simpler interface for people, like sockets, which some people may not think is simple, but it's simpler than what you would have to have done to talk to a networking stack directly.
Keith, this is probably a silly question because I don't know much about Fuse, but the DFS system, I presume that the files that you create, are they just for the lifetime of the process, or is there any way of creating stats that would remain at the end?
Just for the lifetime of the process. If you want to save something that's written into one of those files, you need to save it.
You need to collect it during the process. Okay, thanks.
You need to back it up somewhere.
So my experience shows that whoever wants real performance comes to DPDK, and these guys are already experts. So they want no abstraction layer, they want closest to hardware. If they could have gotten the raw hardware descriptors, they would have done it in some extent.
Yep.
And if you want abstraction layers, so we have sockets, we have Java even, if you want to take it to very simplicity. So I'm not sure if another layer in DPDK is the correct place.
Well, sockets gives you a significant performance hit. Java probably gives you a significant performance hit. Go gives you a significant performance hit in certain cases. All of those other APIs give you a significant performance hit, especially sockets and like read-write semantic. Those are all copy interfaces unless you do something differently. Well, I'm trying not to do copy here, okay? But I am trying to make it simpler for people who want to take their application that's written 15 years ago and they don't want to change it and see if they can get it to move, right?
Yeah, but with sockets, you get layer 4 stack You get so much more than layer 2
Socket,
interface.
socket is a whole nother mess, right? And to tell you the truth, without a, what am I going to do? Oh, I'm going to have you do a socket open raw because that's all I got. I don't have a TCP stack. I don't have a UDP stack. I don't have IP in there, right? Unless you put them in there and do it. Then you have the idea for sockets. Everything else isn't. So sockets just is, to me, a non-starter as far as performance goes. It's only for backward compatibility that somebody's writing sockets and that's all they want to ever see. Great, fine, you can use it as a back starter, but it doesn't fit in this particular paradigm of DPDK. You've got to add the stacks and stuff like that into it somehow. Probably way over my budget here, and he's over here going, what time is that? Uh-oh.
Hi. Just one comment. I think these ideas are very good because my company has been doing DPDK for a very long time, and I have actually been wondering, are our configurations correct at the moment? Because there has been so many changes.
Yeah.
So it would be nice to try some default. Maybe it works better.
Exactly. And I think the setting up the defaults, as Bruce said, do the minimal. Take the defaults. If you don't like the default, allow yourself to change it. And the file system, I think, is going to be an easy way to get stats out or information out or information in. Because I'd love to be able to write into a file that says, oh, you only have 3 L cores? Let me give you 5 L cores. And they just magically spin up for me. Or, oh, you need more memory? I'll give you more memory. My personal thought process on DBKA, it should come up just like Bruce was kind of talking about. Comes up with one thread, not affinitized to anybody maybe, and that's it. There's nothing else attached. And now you can talk to it through the Fuse file system and give it everything it wants. Is that useful? You guys need to tell me that. So I don't know. Okay.
Great. Thank you.
Thanks.